I just want to just highlight a few things. I'm worried really about how much fuzzy thinking is going on in the world. Fuzzy thinking, people just not thinking straight. What we're not valuing is knowledge as process rather than knowledge as an answer. If you're an employer and two candidates come up looking for a job, and you're interviewing the two candidates, and you say, as for part of this interview, I just want to ask you, what's the height of the spire on this building that we're in? And the candidate says, oh, I was an architect. I've majored in architecture for a while, and I memorized the heights of all the buildings on campus. I know. The height of that spire is 150 feet. In fact, 155 feet tall. Okay, turns out that's the right answer. That's the right answer. And the person came up with it in seconds. That person goes away, the next candidate walks in. Do you know the height of the spire on this building? The candidate says, no, but I'll be right back. Person runs outside, measures the length of the shadow of that spire on the ground, measures the length of his or her own shadow, ratios the height to the shadows, comes up with a number. Runs back inside, it's about 150 feet. Who are you going to hire? I'm hiring the person who figured it out, even though it took that person longer, even though the person's answer is not as precise. I'm hiring that person because that person knows how to use the mind in a way not previously engaged. You realize when you know how to think, it empowers you far beyond those who know only what to think. We think, when I say we, just the scientific community, physicists who concern themselves with the very early universe, cosmologists, that the laws of physics as we experience them are set in the very earliest stages of the universe. And quantum fluctuations in everything would be responsible for another universe having slightly different laws of physics than ours. Because the quantum fluctuations will take it in a slightly different law of physics direction than our universe. And this would just keep going. Every universe that's born, even if it started out sort of the same in the very first instant, a later instant when other laws of physics manifest could be slightly different. And with the multiverse, where there could be pockets of the universe that are expanding with no knowledge of any other pockets of the universe. These are essentially independent universes from one another, and never the twain will meet. Imagine you're a ship at sea and you look to the horizon, and that's your whole universe there, to the horizon. There's another ship that has its own horizon, and you declare, this is the universe. And these ships don't even see each other, okay? You'll only see each other if somehow your two horizons can overlap. And we don't know how to do that in our universe because they're it's called non-causal, all right? We don't know how to, you'd have to find some way to tunnel from one universe to the other in order to access that, but that could be very dangerous because if the laws of physics are different than the ones you evolved on, then you could just dissolve into a pile of goo because the charge on the electron is different and all of your biochemistry would change. So the difference in laws of physics comes about because of quantum physics. And there's I don't want to call it random, it's random but predictable. So in other words, you can have a variation in the properties of something and because of the quantum fluctuations that exist within it. And when that's happening in the early universe, you are quantum fluctuating the laws of physics themselves. And that's how you get one universe with a slightly different laws of physics than the other. There could be a universe where the laws of physics there will never allow matter to coalesce. You'll never get stars. That would be a lifeless universe, as far as we can think. There could be another universe where you can make stars, but you don't make heavy elements. That would be a universe with stars, beautiful night skies as we have now, but nothing that we know and love. No planets, no life. Nothing, because our ingredients come from the centers of stars that explode. The manufacturers, the whole periodic table of elements, where does that come from? Exploding stars. Okay? So you can imagine other universes that are not our universe. There could be universes way cooler than ours. Universes where they formed life way faster than ours did. Okay? We didn't have enough ingredients to make life until we can make a planet. Every time a star blows up and it has these heavy elements, it's not enough the first round. You got to accumulate them. And we're like second or third generation supernova here in our solar system. And only then you get enough to have oxygen, carbon, nitrogen, silicon, iron. We got enough. We got a solid planet.
So there's more than one supernova has to take place before enough elements?
More than one generations of supernova. Yeah, you can add up how much that is, and it's feeding the entire galaxy.
So meaning a star has to supernova, and then a new star has to form, and then supernova.
Correct. So you need a few of those generations to get enough density of non-original star material to make things like make a whole balls of planets, for example.
Is it possible?
And even so, it's not very much material. As big as Saturn and Jupiter are, they're made of mostly
gas,
right. Hydrogen and helium that were made in the Big Bang, not made in stars.
Is it possible that there's something else that could be invented or created, rather, when more generations of supernovas occur that hasn't happened yet? Like it took so many generations for planets to...
Very interesting. So we are the product of the mixtures of ingredients that are in this universe. So if you rank the elements in your body, the number one element is hydrogen, contained in the water molecule, because we're mostly water, as you may remember from biology. The next most common atom is oxygen, from the water molecule. Third most is carbon, and we carbon-based life. Fourth most is nitrogen. Well, wait a minute. Those are the top 4 ingredients in the universe itself. In order. Sorry, not including helium, which is chemically inert. You couldn't use it anyway. So it's the top 4 chemically active ingredients in the universe. We're made of that. So you ask a brilliant question. Is there some other universe that has a different mixture of other ingredients, and they opportunistically made stuff out of those other ingredients? What would they be? That's a great question. I have never thought about that. What would a universe be like if it was mostly molybdenum or something? Pick some elements. Pick some random other 4 set of elements and see what you can come up with. You need some chemical activity in it. Carbon is highly reactive with other elements, so that's good. It's not an accident that we're carbon-based. We think other life elsewhere in the universe would be carbon-based because carbon is plentiful and it bonds in so many different ways. If you're experimenting with the diversity of life, carbon is your element to do that on. So this urge to say, let's see if you have silicon-based life. Sure, because silicon sits right below carbon on the periodic table. It makes all the same kinds of molecules. You heard of carbon dioxide, CO2? There's silicon dioxide, SiO2. It makes the same families of molecules. So you can, why not make life? Sure, maybe, but there's 5 times as much carbon in the universe as silicon. You don't have to appeal to silicon. Carbon is there knocking on your door. So for me, what's curious to me is the assertion that if we have a multiverse and there's an infinite number of universes, that means there's an infinite combinations of all things that had ever happened ever, that there's another pair of us having this conversation in another universe, except you're wearing a red shirt and I'm wearing a whatever. I mean, you make tiny changes in what is and say that's happening in one other universe somewhere. And people are wondering, does this give you immortality? If you exist in this other universe, is that really you? If your entire molecular structure is identical, is that really you? And I think people are overstepping there. I don't think it's really you. It's a copy of you, but it's not you. And my evidence for that is if you're a twin, you don't wake up as your twin, ever. Even though you are molecularly identical to each other from birth. You don't share each other's conscience. So one of you is an exact replica of the other, except you're not this.